Good afternoon, everyone, and welcome to Agrifood Conversations brought to you by iSelect Fund, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is David Yoakum. I'm an associate here in the iSelect Ventures team, and I am excited to walk you through today's panel discussion with our fantastic panelists who we have online today. For anybody who's new to these calls, Agrifood Conversations is all about driving innovation in agriculture. Each month, we highlight a specific theme, including emerging topics such as soil health, plant genetics, vertical farming, and aquaculture, to name a few. On today's Agrifood Conversations call, we are joined by Aaron Ratner with Ultra Capital, Joe Ziobro with the Environmental Protection Agency, Connie Bowen, previously with the Yield Lab Institute and currently so as well, and Patrick Mashoff with pigsareus.net. Today's webinar is a panel discussion about the latest innovations in manure technology and some of the fantastic programs that our panelists are working on today. The companies that are currently working on such solutions and the opportunities that we're seeing to help this market develop. Each of you knows that companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in this market. You are potential customers for manure-related products and services. You built or sold a company that is in this space or specializes in this type of technology, or you are a sophisticated business person who understands the market and the challenges it may face. Before we get started, we do have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. And before we, and while we're doing that, a few process comments. We are not soliciting investment. This presentation is to provide information about manure-related products and services to help them find customers, mentors, and other strategic relationships that can help them grow their business. You are all currently on mute. You can use the chat window to ask a question, and after the formal part of the presentation and discussion, we will answer as many questions as time allows. Finally, this presentation is being recorded and will be available for replay. So without further ado, let's jump right in. So we've had this really fantastic month where we focused on a number of really exciting innovations and initiatives that are being worked on by some of the panelists that we have on the call today in the world of manure technologies, but more importantly, nutrient recycling and some of the ideas that are sort of built around this idea of sort of a cyclical economy, and particularly in this idea of manure management. And so today we have Patrick Mashoff, Aaron Ratner, Joseph Ziobro, and Connie Bowen, who are all connected in certain ways and also are working on their own projects on their own. Before we dive into the discussion, it would be great to get an introduction on sort of your general background, but also how you're tied into this sort of manure and nutrient recycling initiative. If we could start with Connie, go with Aaron, Joseph, and then Patrick, that would be great.
Thanks, David. So I'm Connie Bowen, and I am with the Yield Lab Institute now as a board member, but about a little over a year ago now, so the Yield Lab Institute is one of the partners of these organizations and is really just trying to drive more investment in high impact agri-food technologies. And so I had a conversation with my counterpart in organizing this, Sandra Vinn at World Wildlife Fund, over a year ago now, about the opportunity to drive a little bit more commercial scalability in manure management technology, in really, unsexy investment spaces, but specifically manure management technology. So for me, I'm coming kind of from a venture capital investment standpoint, and how do you drive more dollars towards high impact areas? I think, and so I wanted to try and test out this model where we run something like an accelerator for a very specific high impact subsector, and manure tech was one of the most interesting spaces to do this because the potential to significantly reduce greenhouse gas emissions through just improved manure management. This is already a cost center, and I'll let everyone else kind of speak a little bit more to their direct experience and how this kind of impacts their everyday operations. But there's a huge opportunity to have great environmental impact with manure management. So I've been working to kind of bring together this group of stakeholders to focus on helping a couple of startups to kind of get to that next stage of startup growth. So looking at scalable business models that and new technologies that sustainably manage manure, and also creating a quantitative impact model by which we can correlate equity investment in these startup technologies to actual environmental impact. And so I created the Manure Challenge, and that's kind of why I'm on the call today.
Excellent. Well, we're certainly happy that you created the Manure Challenge, and had you not, I'm not sure others would have. So next, Aaron, if we could get a little bit of your perspective, sort of in context of what was said there, maybe a little bit about your background and sort of how you're tied into this whole, nutrient recycling and waste management piece as well.
Absolutely. Can you all hear me okay?
We hear you great.
Great. So I'm Aaron Ratner. I'm a managing director at Ultra Capital. We are a project finance investment firm investing in sustainable infrastructure, which is agriculture, waste, water, and renewable energy. So we don't do venture capital, we don't do private equity. We actually put up all of the capital to build infrastructure projects. In the case of manure management, these projects touch agriculture, obviously, waste and water, and renewable energy. So they cross all four of our disciplines. In our business right now, we're on our second fund. We just raised it. We're building renewable natural gas projects in two of the largest dairies in Arizona, and working on about half a dozen other large RNG projects around the country where we're converting dairy manure into renewable natural gas. We're also working with other forms of livestock manure to turn that into fertilizer and other forms of renewable products. And our business is really trying to put up capital for companies that have developed technologies and processes, but who really need to scale and be very good partners with the large livestock growers in the country who are, increasingly running into very significant issues with the quantities of manure that they need to manage as part of their production.
Fantastic. Thanks, Aaron. Joseph, it'd be great to hear from you.
Thanks so much. I appreciate it. I'm Joseph Ziobro, a physical scientist with the U.S. Environmental Protection Agency, and I work out of the Region 10 office in Seattle, but I also support a range of the animal agriculture related partnership initiatives out of headquarters in the Office of Wastewater Management. And I have kind of the unique position of coming at manure management from both the regulatory and voluntary side of things. So in EPA's Office of Wastewater Management, that is an office that regulates the discharge of pollutants into water, including pollutants that come off of the larger animal feeding operations, CAFOs, as they're commonly known, concentrated animal feeding operations. And however, there's sort of this split between farms based on their size. So we have these larger farms that are sort of within the regulatory purview, and we also have a range of smaller livestock and poultry operations that fall more in the category of what we would call non-point sources of pollution, including nutrients like nitrogen or phosphorus. And there's essentially a recognition in the Office of Wastewater Management that partnership projects can augment our regulatory program and really start to get at some of those issues that can't be addressed directly through regulations. So in that line, the Office of Wastewater Management has a range of partnership initiatives focused around manure management, and very specifically, one project that I'll talk a little bit more about in some time is the Nutrient Recycling Challenge. So from 2015 to the present, I manage EPA's Nutrient Recycling Challenge, which was a little bit of a precursor in some ways to the Manure Challenge that I think Connie's going to talk a little bit more about today. So very pleased to be here and look forward to the conversation.
Excellent. Thanks, Joseph. And last but certainly not least, Patrick, would love to hear a little bit about you and your background and sort of how you came into this.
Yep. So you guys can hear me?
Yep, perfectly.
Okay. I'm Patrick Mashoff. Work for the Mashoffs. We're a pork producing company based in Illinois. We operate in several states within the Midwest region. My background is in environmental services, so everything that Joe just actually described, my team is in charge of making sure that we stay compliant and doing everything to protect the environment. So with that is we go further down the road of innovation with manure application and trying different technologies with the traditional manure application as fertilizer, organic fertilizer source for growing crops. This manure challenge and the companies that the innovation that the companies bring is something that we always want to keep our fingers on to see if there's anything out there that would help protect the environment. Also, if there's any way we can incorporate that into our business or any other businesses within the pork industry or livestock industry, that's what we're looking to do. So it'd be interested to see how everybody's take on what we're going to discuss today. So thank you.
Fantastic. Thanks, Patrick. Well, so Connie, back to you. I mean, like in context here, we've got venture capital, project finance, the Environmental Protection Agency, and the mash-offs. You know, how did this group of people come together on the same project, and sort of how did this all come together into the Manure Challenge?
Yeah, so I'll give a little bit of the story of the Manure Challenge and kind of what it is. But so Sandra at World Wildlife Fund, obviously a conservation organization, right? And I got to talking, and she had been very involved with Joseph in the nutrient recycling challenge, which I'll let him explain in a moment. But essentially, she was talking about how it had been great, and there had been some really cool technologies that came through, but she felt like there needed to be kind of that next level of commercialization. And the Yield Lab, you know, born out of the Yield Lab Institute, born out of the Yield Lab. The Yield Lab was the first ag tech accelerator in the U.S., and we've got a lot of experience kind of working with seed stage ag tech companies. And we have noticed there's a bunch of gaps that we're trying to address kind of in the ag tech investment space. And so we saw this as a really interesting opportunity to pick a subsector, gather a variety of stakeholders, which is how you get this great group on the phone, but also not on the phone, where we've got folks from Cargill engaged, we've got folks from Smithfield and Tyson engaged, we've got folks from the World Wildlife Fund and the Water Research Foundation. We even have WeWork engaged. So we've got really a diversity of stakeholders working together, and I'm sure, and also very engaged and kind of involving in planning this process was Dairy Farmers for America and Nutrient. Really started very focused on the dairy industry, but broad in scope. We created this kind of hybrid prize accelerator model where we solicited applications for manure management technology companies. And we selected 8 of them to participate in this kind of mini non-dilutive accelerator. At the end, there will be a pitch competition, and the companies will have the opportunity to pitch for prize money. There's 8 really cool, exciting companies participating. A couple of them have been on webinars this past month, and all of them can be found at manurechallenge.com. And also, we're coupling that with something that's totally new to my knowledge, and that is this tool that we're leveraging to connect equity investment to actual quantitative impact. So think greenhouse gas equivalent, nitrogen reduction, runoff reduction. There's all sorts of different. We're in the process of building the tool right now, and it's complicated, as are all kind of life cycle assessment tools, but what we really want to do is set a baseline that we can continue to iterate upon, so that investors like iSelect and like the Yield Lab and anyone who wants to make this equity tech investment can not only report on the usual financial reporting, but actually also use this tool to report environmental impact in not just the 8 companies that participate in this program, but any companies that are working in manure management technology. And we, as startups are, there's going to be a lot of them, and they're not all going to work out, but we need to be investing more in this space, and we see this as an opportunity to really highlight how great of an investment opportunity it is, financially and environmentally. So.
Well, I'm really interested in it from this perspective of this analytical tool that it sounds like is being developed in some way, particularly as sort of a life cycle modeling or life cycle analysis tool. And I guess I'd be curious to know from someone like Aaron, your perspective, as you go about thinking about putting together project financing for companies or technologies or projects like this, are there tools that are available to you today that help you really understand what the environmental impact of a project is alongside the economic impact? And are these tools, are they sufficient? Are they limited? Are they even there?
I think it's pretty nascent. I mean, the biggest thing we can count is just the quantity of manure that we divert from open lagoons or land application, and we can convert that into a certain number of MMBTUs of natural gas. So there are some basic metrics that we can use, and you can sort of take that gas you created and follow the math through to, you know, diesel equivalent averted. But it's crude and it's early days, and increasingly what we're hearing from our investors is that they're really focused on us gathering as much ESG data as we can about our projects, because that's actually the correlation between ESG metrics and you know, outcome of the projects is pretty high. So the paying attention to the jobs that are created at these projects, to the way these projects are governed, to the environmental impacts, all of that across the board is becoming a higher and higher priority, and that's driving more sophisticated ways of measuring and articulating the benefits.
Got it. And I mean, are there examples in projects or technologies that Ultra Capital has financed in the past that either based on the limitations of modeling today and based on the limitations of data that's available to you, where projects didn't go as well? And are there examples where a project, you know, did go really well inside the scope of manure recycling and manure tech?
So we're only a few years old, which means we're just now building our first projects, and our manure projects are just about to go in the ground. So it's early days for us as a fund. But if you look across the industry, you can see a lot of projects in manure upcycling that did not work, and the reasons are mostly around the way that they were underwritten, whether the feedstock wasn't you know, contracted properly or measured properly, or there was no proper engineering agreement, or the company that was retained to build the facility didn't have the requisite experience. So there's a litany of reasons why these projects haven't worked out in the past. But as far as Ultra goes, we're just now breaking ground on our first few projects.
Got it. And any projects you would want to highlight at this point?
Well, you know, in California, there are a couple of developers who are doing a really good job of converting open lagoons to what they call clusters of dairies that are capturing the gas and converting it into compressed natural gas for transportation. The two leading developers are California Bioenergy and Moss Energy, and both of them have multiple sites that are up and running at the moment and producing gas, which is really great. In the rest of the country, there are smaller examples of dairy manure in particular, being converted to electricity. So, you know, gas creation and then run right into a generator on site. But, you know, with the price of electricity coming down so much, the price of natural gas coming down, and the value of renewable natural gas going up so much, all of the projects in the sector right now are focusing on creating gas and not electricity. So the conversion there is increasing in that direction.
Got it. Okay, that's really helpful in context. I guess switching gears here a little bit to Joseph. You know, now working on the manure challenge, but in the same context, the nutrient recycling challenge with the EPA has been something that I don't know if it's an annual challenge, but I definitely have seen it occur in the past. Would be curious to know sort of what the nutrient recycling challenge is through the EPA, and maybe how it relates and differs to what you're working on with the manure challenge now.
Absolutely, David. Happy to talk about that. And I think I would start by saying it was approximately 2013 in the Office of Wastewater Management when we started having some earnest conversations with a range of industry trade associations in the livestock and poultry sector about how we can collaborate on some of these issues that might revolve around things like nutrient pollution, non-point source specifically, smaller farms, smaller operations. And, you know, I think we had some pretty ambitious plans, and one of the sort of grounding moments was when we started having these conversations about what sort of projects we could launch. Some of the industry groups came to us and said, you know, what we'd actually like to start with first is some sort of recognition from EPA that manure is actually a resource. And that sort of got us thinking, you know, for much of our history, potentially, you know, it's highly probable that nutrients and manure were talked about as a pollutant only. And that was really one of the early stage conversations we had that got us thinking more about manure as a resource. And so I think we sort of wanted to, you know, we embraced and wanted to see what role we could play in this whole paradigm of recognizing that, you know, manure is a resource, and nutrients, they can be called pollutants, but they can also just be thought of as a resource that's kind of out of place, or too much of it in the wrong place. And so with that said, we had some conversations with some of the stakeholders about innovative manure technologies, just trying to get a sense of what might be out there that various producers were using. And we learned that there were a handful of these new or emerging technologies that were coming onto the scene that were capable of pulling nitrogen or phosphorus from manure and ultimately transforming it into some sort of value-added product. And I think probably the easiest way to describe it would be, essentially taking something like raw manure and potentially turning it into a pelletized or granular fertilizer that can be applied with conventional or slightly modified equipment. And we realize that, yes, there are these technologies out there, but they're not necessarily in widespread use. We think they could offer a lot of environmental benefits going forward, but at the same time, sort of the biggest barriers we identified were that the high capital costs of some of the technologies, high operations and maintenance costs, as well as a lack of or immature markets for the products those technologies can generate. And with all that in mind, we opened this dialogue up to a number of organizations, and ultimately we ended up with this 20 partner planning committee that included, for example, Dairy Farmers of America and the National Milk Producers Federation, Smithfield, Tyson Foods, World Wildlife Fund US, Nutrient, just to name a few, as well as USDA and Department of Energy. And what we were really thinking to do was to craft some sort of program that got a little bit away from the grant paradigm where we give money and hope we get some sort of research or product, and instead play this role using the sort of mechanism of a innovation challenge to spur innovation in a particular area. And probably the biggest goal we had in mind was actually to just start a conversation, because at that time, again, we were aware of the fact that there were technologies out there, but one thing we were certain of after a number of conversations with some of the experts in the field was that the producers and the innovators weren't necessarily talking. So we would hear a lot of ambitious innovators say things like, hey, we can produce a technology that will recover 99.9% of nitrogen and 99.9% of phosphorus and turn it into a fertilizer product. And at the same time, you have producers saying, well, I don't necessarily know that I need to recover 99.9%. Maybe I just want to be able to do a little better liquid solid separation, or maybe only 30% is good enough for me. And even if you did produce that technology, it's too unwieldy and complex and expensive for me to ever consider putting it on my farm. So with that in mind, we wanted to really open that dialogue up, but also do something, in terms of meaningfully spurring innovation. So we ultimately landed on this innovation challenge platform, and we crafted a challenge that was a fairly simple request to the world, where we asked for concept papers for technologies that could recover nitrogen or phosphorus from dairy or swine manure, and do so in a way that was, affordable, and a little loosely defined affordable. And we ended up getting 75 concept papers in from around the world, and ultimately selected 34 of those teams to proceed on into phase 2 of the challenge, which was a design phase, where we'd get a little bit more detail about what the technologies would do, and think of things like blueprints, and actually start to think about building these things going forward. And then I'll just conclude by saying the Nutrient Recycling Challenge was originally envisioned as a 4-phase challenge that would go all the way to demonstration of technologies. So we launched in 2015, and around 2017, after we had completed phases 1 and 2, a number of conversations sort of led us to do a bit of a pivot, because what we ultimately learned is that there wasn't necessarily an appetite to have EPA and these partner organizations through the Nutrient Recycling Challenge try to get to one technology that may or may not be used on livestock or poultry operations, but instead to think about some of the barriers that were critical. And one of those was that there was a lack of technology evaluation programs. So even if technologies were around, there weren't necessarily third-party evaluators of the technologies that would allow those innovators to go in front of investors and say, my technology does this, and here's why I'm saying it does this, because it's actually been validated by someone. So with that sort of critical need in mind, we did a bit of rethinking, and ultimately ended up shifting a bit to work under an MOU with the Water Research Foundation to think of how we can tackle that one particular barrier of technology evaluation programs.
Interesting. And I guess with that, I would follow up with a question to you and Connie as well, that maybe speaks to it, because my understanding of both of these programs is that once there was a challenge in an initiative in place to bring these technologies to some sort of validation that provided the kind of incentives to work on development, that there were a lot of applications, maybe more than you might have expected. And so my question is, are there people who are working on this problem more so that are and they're kept out of the market because the incentives aren't there, or are there a lack of innovators fundamentally because there's not the incentives to go to market? Or is it a combination of both? I mean, I imagine it's somewhat a combination of both, but I'm wondering if it's one more than the other.
At least from my experience with the nutrient recycling challenge, I think it's probably a combination of both. And you know, one of the things that we saw, I think we got an unexpected amount of interest in the challenge with 75 applicants from around the world. We would have been overjoyed if we had 15 or 20. And one of the things that we saw a lot of it were companies and innovators who had been working very specifically in the municipal waste treatment sector come in and say, well, I have this technology and it's actually pretty mature in this sector, and I think with some adaptation we could get it to work in the livestock and poultry sector. And then along with that, I would probably say that, you know, having some conversations with folks like Steve Rowe at Nutrient and others about what's the sort of reason that there aren't more of these technologies out here. I think one of the things I've walked away from those conversations with is this understanding that at the end of the day, even if you are able to generate a product that is, you know, lighter in weight, more transportable, potentially higher value in terms of its nutrient value and the ability to precisely apply those nutrients, given all those things, still at the end of the day, those fertilizer products are going to be competing against bulk commodity prices for nitrogen or phosphorus, and they're just really affordable when you compare the price of those fertilizers to the cost of some of the fertilizers that could potentially be produced using these novel technologies.
Got it. Thanks.
And I would add to that too, similarly surprised by how many companies are active in the space. Specifically, what we were looking, you know, on the manure challenge front, we were specifically looking for companies that had scalable business models, and that so a lot of what we've seen as kind of successful manure management operations has been. They're in California because often they're project-based, which is great and good. But what we're used to working with on the yield lab front, and what we thought we could try to work with here, is what are some ways that you can creatively finance and creatively structure your business model so that you can make this be. Obviously, this can't be a cost center. It has to deliver an ROI. To the producer in order for any of this technology to truly scale. And so then you run into, just creating fertilizer in of itself isn't quite enough. It also needs to be somehow able to be financed up front. It's really interesting because the 8 companies that we're working with here, a bunch of them are producing organic fertilizers, which is very interesting too, particularly with this emergence of hemp, and this year, there's an interesting niche short-term opportunity, at least, for some organic fertilizer to not need to price compete. But more interestingly, I think, or I guess equally interestingly, some of the companies are playing with using carbon credits as part of the revenue model, right? And that just creates a whole different set of risk, but two, it's an interesting way to tie in reward producers for, quote unquote environmental stewardship or whatever it is, right? So that's really what we were looking for here.
Got it. Interesting. I want to bring Patrick into the conversation here because we've talked a lot about initiatives to find new technology and finance new technology. But I think anytime that anybody is involved with ag tech, one of the major issues is associated with adoption and the actual usability of technology and whether or not it actually makes sense from a business case, which is a point you just made, Connie. So Patrick, one question I would have, what kinds of experiences the mash shops have currently, and in your experience as well, with using waste management or waste recycling solutions? What's worked practically? What hasn't worked? What are things that you would need to see for technology to really be applicable in operations that you're working with today? And I guess one add-on to that, I would add, is, are there any sort of user-based innovations that are occurring today where there's actual major problems that they're experiencing at the operation level, where they're innovating at the operation level themselves, simply as a means to keep the business going? So I guess two-part question. One, sort of how are you seeing it? What's working, what's not working from a practical standpoint? And are users actually innovating themselves?
Yeah, so with primarily what I work with is going to be on the pork side. So we don't have as with our lower waste streams per animal unit. It makes it very tough for the some of the past technologies like digesters to work well on hog farms, just because of the volume and the steady volume that you need for those to work. We actually did a pilot project, I believe with Ameren. It's been probably 8 years ago, on a large sow farm that we have with lagoons, and our issue was that we did not have enough volatile solids to make that digester work. It would work, but what it came down to is it would not cash flow, and then we would cause the farm to have two different waste streams to deal with as well. So I think that is the toughest thing, is going to be, can it cash flow? Is the R&M on these types of projects be sustainable? And then what do you do with what kind of a market would you have for the byproduct as well? For us, a majority of our farms are going to be around cropland. So essentially, we work with neighboring landowners to put that manure on cropland as a organic fertilizer or resource, like Joe had mentioned earlier. And if we can't make that waste, if we can't make multiple waste, if we make multiple waste streams, it's very difficult to manage that. And the other issue would be how much capital is needed to get those systems up and going, because all of these manure storage structures, it doesn't really matter what state you operate in, you have a set of regulations that you have to adhere to, and the capital to get that done is significant. So we haven't done that. The digester was the latest thing that we've tried. Now we've actually taken a step back, and we haven't really looked at new technology from a storage structure or separating structure, or mechanical separating structure. We've actually went and invested into better technology on manure application equipment that helps protect the environment and puts a more uniform product down for the crops to be grown. So I guess that's kind of where we're at today. But we actually partner with many farmers throughout the Midwest that constantly ask us, what other technologies are out there other than just bringing us fertilizer value through the manure. And this is one way that with this manure challenge that I think could bring a lot of value, not just to us, but to the industry and to farming in general. So I hope that answered your first questions. Can you repeat the second question?
Well, I guess the second question I have, and it kind of ties into experiences I've had working with other operators, particularly when it comes to the labor issue in terms of in specialty crops, where I've met a lot of growers who are actively involved in projects to try and solve the labor problem, because it's so present in their everyday life. And so when I think about challenges like this as well, like manure management, is it urgent enough at the operator producer level where the actual operators and producers are getting involved with the development of new technologies themselves at that operation level, or if it's not that big enough of an issue for them to really put skin in the game yet?
Well, and like I said, I can only speak from the pork side. I think it's a little bit different than, I think there's a lot of things that are done on the dairy side that where those labor issues could be a challenge. I think the difference is the product that pork produces, that the hogs produce compared to dairy. We don't have as many, I guess, challenges as far as volume of waste produced. Typically, just to give you an idea, on a deep pit finisher, hog finisher, you're going to produce around 1 gallon to 1.2 gallons per pig per day of waste. and you're going to have a very high nutrient content manure. So you're spreading low rate gallons across the acre to meet the nitrogen, phosphorus, and potassium needs of corn and beans. We're located in areas that we don't really apply to specialty crops, so we're applying it more corn, soybean, wheat rotations in the vast majority of the states that we work in. So it's tough for me to answer that specialty crops piece. Labor is always an issue. The labor expense, keeping labor in general is very tough. So that's definitely a concern.
Got it. Okay. Because one thing I'd love to get some perspective on, considering that all of you have been actively engaged in this project and have seen it from different angles and have seen aspects of this outside of the manure challenge itself, are you seeing is there a great spread of different types of technologies that are being applied here? Is it mostly sort of down a couple avenues with slight variation? Is it mostly sort of hardware focused kind of technology? Are there other angles to this? I'd be curious to know sort of what the breadth of technologies being applied to this problem is. And that is to anyone.
I can chime in first and then let other people jump in. But I mean, it's super interesting because we haven't run an accelerator where we have a bunch of companies all working in exactly the same space, right? And so one of my concerns going into this is like, we're going to have competitors. How do we deal with that? Right. But it turns out that most of these things operate in series, and there's such, what works, just like Patrick was saying, what works on a hog farm is not the same thing as what works on a large dairy operation is not the same thing as what works on a small dairy operation. And then within waste separation, there's a bunch of different steps. And then most of what we're working with is hardware-based. What's interesting, though, is many of them have the software component tied in, kind of to the monitoring kind of input-output end, right? And so I think it will be interesting to see in years to come where there's more of an opportunity for pure, quote unquote tech software plays, although I'm strongly biased towards hardware, and I think we should all be investing more in it. But I do think that there will be an opportunity for software play. And I'm thinking really kind of as a utility management, how does that plug into and work with some of the hardware systems that improve utility management, right? But would love anyone else to chime in too.
And this is,
from our perspective, this is a really exciting time in this space. I mean, the manure management is thousands of years old, and in the right quantities, livestock manure is a very good fertilizer. But in sort of modern economy, there are a lot more animals out there. There are 30 billion farm animals on the planet today. And so, Generation 1.0 was open pit lagoons where farmers would just leave the manure in a lagoon, and a lot of it would evaporate, and they would dredge it and take the dried material and spread it on the land. Eventually, people started taking that same waste stream and converting it through anaerobic digestion into electricity, which is what I mentioned earlier. And that's pretty straightforward. There are ways to do that in something called plug flow or tanks, but it's pretty much the same thing where you're just putting that waste stream in a chamber with no oxygen, putting bugs in there. The bugs convert the waste into methane and gas. The next generation, as the cost of technology is going down, the cost of electricity is going down. What's happening right now is there's a big land grab running to convert manure, particularly dairy manure, but also swine and eventually poultry, into natural gas for consumption in the California market. That's around the low carbon fuel standard, and that gas is very valuable. So the gas coming out of the Bakken right now is $2 or $3 an MMBTU. Transportation fuel gas in California, if it's coming off of a dairy, is worth $60 or $70 an MMBTU. So it's very, very profitable output from what was considered a waste stream earlier. And the next generation of technology, and this is what the Yield Lab's doing that's so exciting, is startups that are taking that same waste stream and not just converting it into gas, but converting it into industrial material, whether it's forms of carbon or feeding that waste stream to insects, and then actually taking the insects that are eating the waste stream, crushing them and feeding them as a form of protein and fat back to the livestock, which is kind of one of the ultimate upcycling circular economy plays. So the transition and the evolution in this sector is accelerating. Cost of technology is going way down, the innovation's coming way up, and simultaneously, the scale of the problem is really big in the United States. With climate volatility, you get a lot more flooding, a lot more natural disaster, and anywhere where you have open lagoons, that's a huge risk for farmers because their waste stream can end up in the local waterway, whether it's a bay or a river. So, animal farmers in general, now that they're under much more pressure to be sustainable around the way they treat their animals, obviously the plant-based protein space is coming on strong and putting a lot of pressure on dairies and meat farmers. But those farmers are also under pressure to not have any environmental issues. So they're very worried about issues that in the past they were able to just land apply. So it's a really interesting time to be involved.
Interesting. Joseph, anything you'd like to add?
Yeah, I think Connie and Aaron captured a lot of it. I can briefly say from our experience in the nutrient recycling challenge that we sort of saw the full gamut of technologies, ranging from the thermal technologies that, in some cases are resulting in an ash or a biochar type product, but also some energy generation potentials that go along with that. We saw technologies that were biological, chemical, mechanical, and sort of the full suite. And some of the products that we saw that were a little more sort of typical, or at least well established in the municipal waste treatment world, were things like struvite, which is magnesium ammonium phosphate fertilizer, precipitation along with ammonium sulfate fertilizer production, and it could also some of the technologies could yield things like fiber products. And we've not necessarily in the context of the nutrient recycling challenge, but like Aaron was just saying, there is sort of this whole new emerging world too, where there's looking at some of the extracting amino acids and crude protein from and not just thinking about nutrients alone. And I know of at least one company out there in the world that I think is producing clothing from manure-derived products. So there's kind of a full suite of opportunities out there.
Excellent. And I guess I know you guys touched a little bit on this inside that scope, but one thing are there any like really particularly high, any opportunities inside manure technology that you really see as being, high growth, unique opportunities within that scope of technologies? Is there something that people should be particularly paying attention to inside that scope?
I think I'm starting to think that it's very interesting. One of the barriers, I think, to having a lot of these various technology, basically extraction technologies that are going to separate phosphorus, nitrogen from the manure, so that you can have kind of a pure fertilizer, right? There's an issue where these companies have to both build the technology and then market that fertilizer. I think it would be fascinating if there was a fertilizer marketplace that kind of aggregated some of this and did some of the marketing for that. I don't know how that could come to be, but it seems like an interesting opportunity that I'm not seeing.
Got it. Okay. Interesting.
Yeah, part of the challenge in the fertilizer space, though, is it's a very opaque market, and there's not a lot of clear pricing and standardization. So for startups coming into the space who are trying to create a product for sale on the market, it's really hard to identify the end customer aside from a single company that says they're going to buy the product. And at the moment, there are no long-term purchase orders for the product. So if you're a startup and you're trying to raise money to go build a facility that's going to convert, say, poultry litter into fertilizer, you can't get anyone to promise you they're going to buy it. They might tell you they will, but they won't sign a contract for it. And so it creates a real obstacle to the financing as well.
Does it make more sense for an operation to go vertical with a technology like that if they've got enough manure and then enough operations that have use for that type of manure? Are there any examples of that where, this might be an example of somewhere where the mash shops could come into play, where somebody has an extremely large animal operation as well as use cases for the manure, at least from an agricultural standpoint, so much so that they sort of create their own balance inside their own operation?
At the moment, across the industry, the farmers who have attempted to do that have not succeeded. And that's because these projects, while they seem very simple, they're really hard to put together and to run properly over the course of 5, 10, or 20 years. And that requires a lot of industry expertise. You need to understand how to structure all the contracts. You need to understand how to build the project specific, on specification. And then you have to run it properly. And a lot of the, anybody running a 10,000 head dairy today is up at 4 a.m. and works till, past sunset already. So they don't have the bandwidth to do it.
Right.
Oftentimes they don't really have the balance sheet to do it. So, and then that's obviously the Kool-Aid that we drink every day, which is we can help people with this. But so far, there has not been any vertical integration. It's been too complicated.
Got it. Okay. Do you see it being possible going forward, or is that just it's just not really realistic inside the bounds of, how these things really work?
It will start to happen more and more as companies realize that the fate of their waste streams is directly tied to their corporate brand and their consumer base. If you look what happened at the Fair Oaks Dairy, right? They had somebody videoed a cow being abused, and all of a sudden mothers weren't buying that milk on the shelves across the East Coast, right? So there's very, very little room for error in the consumer space with these companies, which means the stakes around the environmental impact are going way up. And so companies will start to pay much more attention to this, and eventually they may start to implement it. But the cost of building these facilities is quite significant. The cost of running them is hard. And once you get them up and running, then you really have to keep them operating. The average dairy cow, creates about 80 pounds a day of manure. So if you have 10,000 of those animals, you've got a lot of flow every single day that you have to do something with. And if you make a mistake and you can't run it through your system, you have nowhere to put it. So for a while, at least, we think that the people with decades of expertise will continue to lead the sector. But on some of the more distributed, smaller farms, it's possible that you'll see farmers bringing it in-house and vertically integrating.
Got it. Okay. Well, that would be really interesting to see.
And also, one example of that actually participating in the manure challenge is cow pots, which I think did a Agrifood Conversations webinar too. But yeah, they're interesting in that they're not selling fertilizer; they're selling biodegradable pots and also like packaging materials. And that becomes interesting because that's theoretically what can be a consumer branded higher margin kind of product, right? So that, but that, it's difficult to do everything. So there's risks in that, but, we think it's a really interesting, and potentially scalable concept. So we like them.
Cool. Okay. Cow pots. Any other companies that should get a shout out here that we should know about, or that listeners should know about?
It's a long list. Go to the Yield Lab website.
That is a good idea. Well, we've only got a few.
Pick favorites.
Oh, go ahead. we're
not allowed to pick favorites.
Okay, that's fine. I'm okay with that. We've only got a few minutes left here. We could talk about manure all afternoon, it seems like, or for longer if we had the time. But I do want to give the audience a chance to ask questions. You have one question that's in the question box currently. If you do have questions, do feel free to type away, and I will read them out accordingly. If you can make them legible, that would be fantastic. Otherwise, I don't want to butcher your questions. One question is pretty straightforward, and I think it's probably directed to Connie at this point, unless you're planning on handing off the reins of the manure challenge to anybody sometime soon. Do you expect the manure challenge to be an annual event, or is this the only time we're going to be doing it?
Yeah, no, that's a really interesting question, and one that I'm still kind of asking. So, this is continuing to be run by the Yield Lab Institute, which I'm still engaged with from a board, but not an operational perspective, really. So Brandon Day is really kind of running the show right now. But we have had a bunch of conversations with kind of taking this internationally. But we really focused on the U.S. market with this initial challenge, because it's been our experience. You got to have the people on the ground and understand. You have to understand the space that you're trying to work in if you're going to try to help companies work in that space. But there's a lot of interest. I don't know if people have been kind of following the news. I guess last week this was, but am I going to say someone here? Is Norway where they were where the dairy farmers were protesting on the? No, the Netherlands, right? That there was a big protest last week because in order to meet greenhouse gas reduction goals, it looks like the burden might fall to the dairy farmer, right? And a lot of emissions due to that are going to come out of manure. So there's broad interest in kind of continuing something like this internationally, but we haven't really nailed down what it looks like. For this year's challenge, we have 2 more programming sessions. One is at the Sustainable Ag Summit in Indianapolis in November, and then we'll have our final pitch competition in San Francisco alongside the World Agritech Forum, the one in March in 2020. And I'm not exactly sure what we'll do after that. We'd like to continue to drive dollars towards the space and do so in a thoughtful and resource efficient way. So basically, we're open to ideas, and hopefully we'll continue to do something. I don't know what it will be exactly.
Okay, excellent. We do have one more question. Kurt from Smart Pots. Kurt, it looks like you raised your hand. I'm going to unmute you temporarily so you can ask your question. If your question has already been answered, you can feel free to just pass on the question, but I'm going to unmute you and feel free to fire away. Kurt, the floor is yours if you'd like to ask your question. Looks like we're going to go with no question here. Thank you, Kurt. So one other question that came in here. Solid waste is one thing. What about dealing with toxic gases, which are a major health risk? Does anybody on the panel feel like they can speak to that question?
What is the source of the toxic gas? What does that mean?
I'm assuming it has to do with some sort of toxic gases being released either from manure or from some sort of fermentation process. I'm not totally sure.
So let's assume it's a manure question. I mean, if you go to an open pit lagoon in the Central Valley of California in the summer, that lagoon is bubbling like a freshly poured glass of champagne. So there's a lot of gas coming out of these. If you put that manure through a digester, you will get very toxic gases. There's a lot of sulfur, there's a lot of ammonia, and you need to scrub that gas and clean it up if you're going to sell it into a pipeline. And there are available technologies for doing that. Where these projects get into trouble is they start creating gas and then they just have to flare it and just burn it, which is not much better for the environment than just leaving it out in the field.
Got it. Well, it seems we have come up to the end of our hour here. This has truly been a really, really interesting conversation. One thing we like to give all of our panelists anytime we host an Agri-Food Conversations is an opportunity for them to ask the audience for things that they might need or a way to contact them if in the event that they'd like to be contacted to learn more about your involvement with Manure Challenge or other things you're working outside of that. So if we could go Connie, Aaron, Joseph, and Patrick, some ways in which the audience can get in contact with you going forward, that would be great.
Sure. Thanks, David, very much for hosting. This was fun and thanks all for joining. If folks want to learn more about the Manure Challenge, you can go to manurechallenge.com. Definitely check out some of the companies. If you want to learn more about any piece of that, be it an introduction to a company or learning about kind of ideas for what we do next, because like I said, we're open to it. You can just email me at Connie, CONNIE, @theyieldlab.com, and I will connect you with my team.
Got it. Thanks, Connie. Aaron?
We're always looking for more projects to do in this space. I'm very available on LinkedIn. My email is aratner@ultracapital.com, so I'm always responsive on those mediums.
Thanks, Aaron. Joseph?
Yeah, EPA certainly welcomes all manner of collaborations in this sort of manure management voluntary program arena, and anyone can reach out to me with questions about voluntary partnership projects or regulatory questions. Might be a little more boring of a conversation if it's a regulation conversation, though. But with that said, our email addresses at the EPA are our last name dot first name @epa.gov, so ziobro.joseph@epa.gov. And if you'd like more information about the Nutrient Recycling Challenge, you can go to nutrientrecyclingchallenge.org.
Excellent. Thanks, Joseph. And Patrick?
Yep. I welcome anybody to contact me if they have any questions or if there's any other opportunities. My contact information is patrick.mashoffs@pigsrs.net. You can also check out the mashoffs.com and find out contact information on there as well.
Excellent. Well, thank you so much to all of our panelists, not only for your thoughtful insight, but for the exciting and important work, frankly, that you're doing with the Manure Challenge and the other projects that you're involved with. So we certainly appreciate your time and the hard work you put into this. And I think we're all looking forward to seeing what kind of companies come out of this project and what kind of innovations are kind of spurred by the incentives that you put to work. So thank you for your time and for your work. For our participants today, thank you for participating on this webinar. If you would like to learn more about the Manure Challenge, nutrient recycling, any of the fantastic work that we've learned about today, please let us know by answering the following poll. We host these calls every week at 3 p.m. Central Time. You can register for the Agrifood Conversations webinar series by going to agrifoodconversations.com. Replay of this webinar will be emailed to you in the next 24 hours. And if you know others that may want to see this webinar on replay, they are able to do so at the agrifoodconversations.com website within the next 24 hours. Thank you again to our panelists. Thank you again to our participants for joining today. And we look forward to seeing you next week. Thank you.
Thanks.
Thank you, Dave.
Thank you.